Hello everyone and welcome to the fourth video on decimals. This is a technical skills video and the topic of this video is on rounding decimals. Now let's first make sure that we understand what people say when they say something like round a given number to a given place value. So I'll go through this by giving you examples. Suppose someone says round a given number to the nearest 10. What this means is that we need to find integral multiples of 10, that the integral multiple of 10 that is closest to the given number. The integral multiples of 10 are negative 30, negative 20, negative 10, 0, 10, 20, 30, and so on. So basically 10 is multiplied by an integer. And the idea when someone says round a given number to the nearest 10 is to find out which of these multiples of 10 is closest to the given number. And in a similar way, when someone says round a given number to the nearest 100, this means find the integral multiple of 100 that is closest to the given number. And the integral multiples of 100 are negative 300, these are some examples of them, negative 200, negative 100, 0, 100, 200, 300. So basically we jump in steps of 100. And again, round a given number to the nearest 100 means find which of these numbers, which are integral multiples of 100, which of them is closest to the given number. And again, if someone says round a given number to the nearest 1000, it means find the integral multiple of 1000 that's closest to the given number. And the integral multiples of 1000 are negative 3000, negative 2000, negative 1000, 0, 1000, 2000, 3000. You jump in steps of 1000. We can of course talk about rounding a number to the nearest unit, which means find the integral multiple of 1 that is closest to the given number. So basically, which of these numbers, which are the integral multiples of 1, which of these is closest to the given number. And now on the fractional side, if we say round a given number to the nearest 10th, it means find the integral multiple of a tenth, or 0.1 that is closest to the given number. And anytime you want to find integral multiples of a number, you multiply that number by integers. So for example, 0.1 times 0, then times 1, then times 2, times 3, and also on the negative side, times negative 1, times negative 2, times negative 3, and so on. So the integral multiples of a tenth are negative 0.3, negative 0.2, negative 0.1, 0.0, 0.1, 0.2, 0.3, and so on. Now when we say to the nearest tenth, we need to show the tenths, so that's why I write 0.0. And the question is, which of these integral multiples of 0.1 is closest to the given number? We can talk about rounding a number to the nearest hundredth, and then again it means which of the integral multiples of 100th are closest to the given number. And of course, rounding to the nearest thousandth means find the integral multiple of 1000th that is closest to the given number, with integral multiples of 1000th being negative 0.003, and so on and so forth until we get to 0.003, and so on. So now let's say that we will focus for a bit on rounding to the nearest 10, and then we'll extend the idea to other place values. Problem number 1, round 342 to the nearest 10. And in order to do this, the idea is to find the multiple of 10 that's closest to 342. And remember that multiples of 10 are negative 30, negative 20, negative 10, 0, 10, 20, 30, and so on. And if we continue in this manner, jumping in steps of 10, eventually we get to 100, 110, and then 200, and then 300, 310, and 320, 330, 340, 350, and 342 is sort of sandwiched between 340 and 350. And so the idea is to find which of these multiples of 10 is closest to 342. From the diagram, we can of course say that it's 340, But to have a systematic way so that we don't have to always draw diagrams or even visualize them, if we can just quickly get it done, we can follow this kind of algorithm that pretty much works all the time when you round decimals. And this is amazing. There are no ifs or conditions, or it works under certain cases but not other cases. This approach works all the time. And what I'll do is, by going through examples, every time I show you how you can follow this algorithm to round a decimal to a given place value. This is nice because having one rule that's simple enough to understand and easy to apply is just what we love to have. And so the approach is now on the diagram on the right side. The approach is to if I'm rounding 342 to the nearest 10, which is what this problem is asking for, I have underlined the tens just so that we have an eye on it as we talk about the algorithm. So we want to round to the nearest 10, which is here. And if you take a look at the diagram here, you'll notice that 345 falls between 340 and 350, between the two multiples of 10 here. And in order to figure out whether 342 is closer to 340 or 350, we can compare it to 345. In fact, what happens is that we compare the digit 2, the digit on the right side of the place that we want to round to. We take a look at that digit, and that one will tell us, if we compare it to 5, it will tell us whether we are closer to 340 or the next multiple, which is 350. If the digit here is less than 5, then we are in the area here, and therefore it rounds down to 340. If this digit is more than 5, then we are over here, and this rounds up to 350. So the algorithm is find out the place to which you want to round, in this case tens, then take a look at the digit on the right side, and if this digit is less than 5, 4 stays the same, we get 340. And if this digit is more than 5, then we go to the next multiple of 10, which is 350. In all cases, the digit here becomes a 0. Alright, so in this case we end up with 340 as the answer. Okay, problem number 2. Round 348 to the nearest 10. And again, what this means is find the multiple of 10 that is closest to 348. Multiples of 10 are here, from negative 30 to 30, but as I said, this list continues. We can go on to 40, 50, 60, 70, and then eventually 100, 110, 120, jumping in steps of 10 because we want to round to nearest 10. And eventually we get to 320, 330. Let's now go to the next image. 320, 330, 340, 350, and so on. And again, 348 is between 340 and 350, so it will round to one or the other. And to figure out to which one, we need to find out to which of the two it's closest to. And we compare that to 345, again, the midway point between 340 and 350. And you notice that the algorithm that I was just talking about works in this case as well. So if you're rounding to the nearest 10, we compare the next digit to 5. If it's more than 5, then we are up here, and we should round up to 350. And if this digit, like the previous problem, is less than 5, then it rounds down to 340. So 8 being more than 5, we add 1 to 4 to go to the next multiple, and we get 350. Now if I can compare this to the previous case, where we had 342, if 2 is less than 5, then we don't change 4, and so we go down to 340. But if the digit is more than 5, then we increase 4 by 1 to go to the next multiple, which is 350. So less than 5, leave 4 alone. More than 5, add 1 to 4. Right, so the answer to this problem is 350. Okay, problem number 3. Round 345 to the nearest 10. Now this one is an interesting problem. Again, it means find the multiple of 10 that is closest to 345. This is an interesting problem because 345 is exactly halfway between 340 and 350. And so it's equally close to 340 and 350. Now we need to deal with this dilemma in some way, and the agreement is that unless there are reasons why this is not a good idea, then by convention we always round the halfway point, we push it up. So in this case 345 becomes 350. Now again, in most cases this doesn't really pose a problem, but in some cases it may, and if it does, such as in some cases in finding averages in statistics, you might find that pushing the halfway point up all the time can sort of affect the outcome of the problem you're working on. And in those cases, there are methodologies that sometimes push the halfway point up and sometimes they push it down. But in any case, here I'm going to stick to the basic way of doing it. And the agreement is that if it's not detrimental to the problem that you're working on, then we always push the halfway point up. So if the digit is 5, which is exactly halfway, then we add 1 to 4 to get 350. So again, the algorithm that I was talking about works here as well. 345, we want to round to the nearest 10, and therefore this is the place value to which we want to round. We take a look at the next digit, 5, this is halfway, and if it's equal to 5, we push 4 up. We add 1 to 4 to get 350. Now this approach is of course pretty interesting in the sense that it works because of the relationship between the sizes of place values. So because each place value, such as a 10, is always divided into 10 parts, 5 will always be the halfway point. Okay, so we have 350 for this problem. Let's move on to the next one. This one is an interesting one. Round 3 to the nearest 10. And again, the question is what multiple of 10 is closest to 3? And these are the multiples of 10. Now, the diagram is given over here with multiples of 10 starting with 0 going up, 0, 10, 20, 30. And you notice that the multiple that 3 is closest to is actually 0. And what's interesting is that the algorithm that I was talking about still works. If we are rounding 3 to the nearest 10, this is where the 10s are. And there is a 0 there right now. And therefore, because 3 is less than 5, we do not touch the 0 here. And we end up with 0 by dropping the 3. For problem 5, round 3,496 to the nearest 10. Now for this problem, if we jump in steps of 10, eventually we will come to 3,480 and then going up by 10, 3,490 and 3,500 and so on. And the idea is to find again the multiple of 10 that is closest to 3,496. Now in this case, we have sandwiched 3,496 between 3,490 and 3,500. And again, to figure out which one it's closest to, we take a look at the digit that follows the 10s, which is a 6. And this is more than 5, which means we are closer to 3,500. And therefore, we can follow the algorithm that we had. It still works. If we are rounding to the nearest 10 and we have a digit here that is more than 5, then we add 1 to the 10s. We push it up by 1. And that 1 carries over and turns this into 3,500. So again, round to the nearest 10. 6 is more than 5. We add 1 to 9. And we get a 10. Carries over, we get a 5. So 3,500. Next problem, round 470 to the nearest 10. Again, as usual, it means find the multiple of 10 that is closest to 470. Now in this case 470 falls right on a multiple of 10, which is 470. But we can still follow the algorithm that I was talking about. We can take a look at 0, and because it is less than 5, we're going to leave 7 alone. So again, 470, we are rounding to the nearest 10. The digit that follows is less than 5. So we do not change 7. And of course, everything past the place where you round becomes 0. Okay, so the answer is 470. Next problem, we want to round. Now this one has a decimal in it. Like so far we have been talking about numbers that that don't have a decimal digit, or they don't have decimal digits, but in this case we do have a fractional part. Round 142.68 to the nearest 10. The idea is the same. We want to find the multiple of 10 that is closest to 142.68, and these are the multiples of 10. And if we keep counting in tens, eventually we'll come to 120, 130, 140, 150, and so on. And 142.68 is somewhere between 140 and 150. Now, what's interesting here is that all we have to do is compare the digit that follows the tens, the place we want to round to. That would be the 2. We just have to compare the 2 to 5. The rest, 0.68, are not going to have any effect. So long as 2 is less than 5, the 6 and the 8 could even be 9 and 9, and that would be still less than 5. Think money. $142 and whatever cents will be less than $145, and therefore the cents really don't matter. Same thing with decimals in general. We don't really have to worry about the 6 and the 8. So long as 2 is less than 5, we are below the halfway point and we round down. And so the algorithm is as follows. Find the place you want to round to. Take a look at one digit that follows. If it's less than 5, 4 doesn't change. And we end up with 140. And you can see from the diagram that it does work. Okay, so that was rounding to the nearest 10. Now rounding to the nearest 100 is pretty much the same. Problem 1, round 627 to the nearest 100. And now we want to find the multiple of 100 that is closest to 627, and these are multiples of 100. Here's the diagram. 627 is between 600 and 700, jumping in steps of 100 now. And again, what's interesting here is that we can compare the digit that follows. Now this time we are rounding to the hundreds, and therefore the digit that follows will be in the tens. And so long as this digit on its own is less than 5, we are below the halfway point. You notice that what follows doesn't matter again. You can even have a 9 here instead of 7, and that would still be less than 650. So long as we have a 2 here, it will be less than 650 no matter what digit follows. And therefore all we have to do is follow the same algorithm. We are rounding to the nearest 100 now. We look at one digit that follows. If it's less than 5, we are below the halfway point, and therefore 6 does not change. We get 600. Problem 2, round 1793 to the nearest 100. And as usual, we need to find the multiple of 100 that is closest to 1793. Now the image is over here. And as you can see, jumping in steps of 100, eventually we'll come to 1500, 1600, and so on and so forth. 1793 is in between 1700 and 1800. And again, to figure out which it is closest to, you take a look at one digit that follows, the 9. We are rounding to the nearest 100 where the 7 is, and we look at one digit that follows. And so long as this is larger than 5, we are above the halfway point. It doesn't matter what the digit that follows is. It can be as small as 0, and we are still above the halfway point. So all we have to do is just take a look at one digit that follows. Now without a diagram, we would reason like this. We are rounding to the nearest 100. we take a look at one digit that follows, and if it's more than 5, we are above the halfway point. 7 goes up by 1, and we get 1800. Now rounding to the nearest 1000 is similar to rounding to the nearest 10 and rounding to the nearest 100. I guess we have one example here, round 4268 to the nearest 1000. Now this time we have to find the multiple of 1000 that is closest to 4268. And these are some of the multiples of 1000. The image on the right side. Now rounding to the nearest 1000, jumping in steps of 1000. 4268 is between 4000 and 5000. And again, you notice that in order to figure out whether it's below the halfway point or above the halfway point, we just need to take a look at one digit that follows, the 2. And if this is less than 5, we are below the halfway point. One more time, it makes no difference what digits follow the 2. You could have 9 and 9, and it's still less than 4500. So the algorithm is find the place you want to round to, that's thousands. Take a look at one digit that follows. And if it's less than 5, then 4 does not change. And so we get 4000. Everything past the place you want to round to becomes zeros, of course, because we want to round to the thousands. So it will be something like 4000, 5000, and so on. Okay. Now, in case you want to round negative decimals, such as the problem round negative 480 to the nearest 100. It means the same thing. We need to find the multiple of 100 that is closest to negative 480. And these are multiples of 100. Now in the case of negative 480, we are here. And remember that with decimals, or with integers also, on the negative side, the number that has a larger size is actually the smaller of the two. And here negative 480 therefore falls closer to negative 500, and it should round down. Size-wise it becomes bigger, it appears, but it rounds down in any case, and we get negative 500. Now in order to round, what you can do is you can round the positive part. So in fact what we do is we take a look at 480 instead of negative 480. Although you could actually write a negative down to begin with, that won't change anything. But the rule applies. We take a look at the digit that follows. If it's more than 5, we have to add 1 to the 4, and we get 500. And therefore the answer to this problem is negative 500. Now on the fractional side, if we want to round to the nearest 10th, problem 1, round 3.42 to the nearest 10th. And the idea is to find the multiple of 0.1 that is closest to 3.42, and these are multiples of 0.1. In terms of diagrams, we have 3.4, so jumping in steps of 0.1, eventually we get to 3.2, 3.3, 3.4, 3.5, and 3.42 is in between 3.4 and 3.5. And if we take a look at how it compares to 3.45, which is halfway, then we notice that it's below the halfway point. And again, rounding to the nearest 10th, we take a look at one digit that follows. And if it's less than 5, we are below the halfway point. If it's more than 5, we are above the halfway point. In this case, we are below the halfway point, and therefore when we round, we get 3.4. Now take a look at how it works again. 3.42, and we are rounding to the nearest 10th. Take a look at one digit that follows. If it's less than 5, 4 does not change, and we get 3.4. Now when we say round to the nearest 10th, the tenths should be the last thing that you show. Remember that this one of these numbers will be the one that it rounds to, and these numbers stop at the tenths because we jump in steps of tenths, and therefore everything after the place you round to will be pretty much wiped out. Okay, so 3.4. Problem number 2, round 3.48 to the nearest tenth. And in this case, we need to find the multiple of tenth, or 0.1, that is closest to 3.48. And the diagram is here. Now again, we compare this to 3.45. Now this also relates back to what I was talking about in the first video on decimals, on the structure of decimals, where I said that each place value divides into 10 parts as we go downstream. And here the tenths, which is the distance from here to here, divides into 10 parts, and therefore that's the reason why the 5 here is in between. So from 3.4 then we get 3.41, 3.42, 3.43, 3.44, and then 3.45. Each of these digits that follows the 4 is a subdivision of a tenth. And so 10 of them will take us from 3.4 to 3.5, and therefore 5 here, digit 5, points to the halfway point. And so if I'm rounding to the nearest 10, then I take a look at one digit that follows, and if it's more than 5, we are above the halfway point, and we push it up to 3.5. So the algorithm, as usual, there is no change in it, is rounding to the nearest tenth. We take a look at the digit that follows, and if it is more than 5, we add 1 to 4, and we get 3.5. Once again, it's important to note that you have to stop at the place where you round to on the right side, because this is what we have. We need to end up with one of these numbers, 3.2, 3.3, 3.4, jumping in steps of 0.1. Okay, problem number 3, round 3.45 to the nearest tenth. Now this is the same as the problem that we had earlier without the decimal point, where we had the halfway point. And in this case as well, we are exactly at the halfway point, 3.45. And as usual, we push up. The algorithm still works. 3.45, we are rounding to the nearest tenth. What follows is 5 or more than 5. We push 4 up, and we get 3.5. Number 4, round 0.03 to the nearest tenth. And as usual, we have to find the multiple of 0.1 that is closest to 0.03. Now in this case, 0.03, we are rounding to the nearest tenth, and taking a look at the digit that follows 3 tells us that we are below the halfway point, and therefore it rounds down to 0.0. The algorithm still works. We are rounding to the nearest tenth, take a look at the digit that follows, and if it's less than 5, this digit 0 does not change, and we get 0.0. Now remember that because you're rounding to the nearest tenth, just to be clear about that, we put the 0 in the tenths, and that means that this has been rounded to the nearest tenth. Okay, problem number 5. Round 34.96 to the nearest tenth. And as usual, we have to find the multiple of 0.1 that is closest to 34.96. Here's the image, jumping in steps of a tenth. We have 34.8, 34.9, 35.0, and 34.96 is somewhere in between here. Now, in order to figure out what we need to do is, what we can do is to compare digit 6 with 5. And because it's more than 5, we are above the halfway point, and therefore it rounds up to 35.0. The algorithm still works. Rounding to the nearest tenth, 6 is more than 5, we add 1 to 9, and it carries over. So 1 plus 9 becomes 10, we put the 0 down, carry the 1, and we end up with 35.0. Again, it's important to write the 0 down because it tells us that we have rounded to the nearest tenth. In fact, dropping the 0 would round to the nearest unit, and these two are not necessarily the same. And I will discuss this in more detail later on when we talk about measurement systems. For now, you may want to just keep in mind that 35.0 is a more accurate kind of a measurement because it's within a smaller division compared to 35, which would fall within a larger division of a unit. Alright, next we have round 4.7 to the nearest tenth. And in this problem, as usual, we have to find the multiple of 0.1 that is closest to 4.7. And in this problem, 4.7 appears to be right on the dot. It's right on one of the multiples of a tenth. And therefore, the answer will be 4.7. The algorithm still works. If we write down 4.7, we are rounding to the nearest tenth. What follows is a 0, which we don't write down, of course. And because it's less than 5, 7 does not change. And we get 4.7. Now, rounding to the nearest hundredth is pretty much the same. Problem 1, round 0.0627 to the nearest hundredth. And here we have to find the multiple of 100th, 0.01, that is closest to 0.0627. And these are multiples of 100th. And the image for this problem, we have, if we keep counting in steps of 100th, eventually we get to 0.04, 0.05, 0.06, and so on. And 0.0627 is in between 0.06 and 0.07. And then we take a look at how it compares to the 5 that follows. Now we are rounding to the nearest hundredth. And that would be pretty much the distance. That's the hundredth from top to bottom here. And what we can do is divide this into 10 parts, and then we get 0.061, 0.062, 0.063, and so on. And so the digit that you see here is represents 1/10 of a hundredth, 1/10 of this distance. And that's why, again, 5 is a halfway point. And because 2 is less than 5, we are below the halfway point. You notice that 7 doesn't matter again. It could even be a 9 and we would still be below the halfway point. Okay, so we follow the algorithm. We are rounding to the nearest hundredth. Take a look at one digit that follows, the rest don't matter. And if it's below 5, we are below the halfway point, and 6 does not change. Problem 2, round 4.1793 to the nearest hundredth. Now we have to find the multiple of 100 that's closest to 4.1793. And here is the image. Now here 4.17, we are jumping in steps of 100th, and therefore 4.1793 is in between 4.17 and 4.18. We take a look at the digit that follows the 9, and that places the number way above the halfway point, so it is closer to 4.18. And here we can follow the algorithm that if we have a 7, if we are rounding to the hundredths, to the nearest hundredth, then we can take a look at one digit that follows. And again, if that's more than 5, we are above the halfway point, and we push 7 up by 1. Now here again we stop at hundredths because we want to round to the nearest hundredth. As you can see, the answer can be one of these. So they all stop at 100th. Okay, so before I end this video, 2 things you should remember. One is that if you're rounding 347 to the nearest 100, and of course you get 300, the thing to remember is that you cannot round twice in a row. So sometimes people wonder, if I'm rounding to the nearest 100, is it possible to round 347 to the nearest 10 first to get 350, and then because we have a 5, when we round to the nearest 100 we get 400? And the answer is no, you cannot do that. You only round once according to the rules that we talked about. You notice that if you round twice, you'll end up with a value that you don't want to get, because when we talk about rounding, we want to find to the nearest 100, we want to find the multiple of 100 that's closest to the number that we have. And if you take a look at 347, which falls between 300 and 400, you notice that it is below 350. So whatever approach that you use, eventually we would like the answer to be 300, not 400. And the problem with rounding twice is that when you round to the nearest 10, you effectively push 347 up to the halfway point, and then you push it up again to the nearest 100. and that's not what we expect. So this approach doesn't give us what we want. We would want to get 300 for 347 because it's closer to 300 than 400. So you may not round twice in a row. You may not round to the nearest 10 first and then round to the nearest 100. That's one thing to remember. And the second thing to remember is how rounding a positive number relates to rounding a negative number that has the same size. And in this case, the answer for rounding 480 to the nearest 100 would be 500, and for negative 480 it would be negative 500. To show you how, in this diagram, 480 is closer to 500 compared to 400, with 450 being in between. So it rounds up to 500. Now if we go on the negative side, negative 480 is closer to negative 500 compared to negative 400. So you can see on the positive side we are closer to 500, and then on the negative side we are closer to negative 500. And therefore when you round, that's why if you're rounding a negative number, you can always round the positive one and then put the negative sign next to it. And there we have it, the relationship between roundings of positive and negative values of the same size to the same place value. You get the same size, but the one will be positive, the other one will be negative. Okay everyone, that was a bit of a long video, but we are at the end of it. Thank you again very much for watching this video, and if you have any comments for any of the videos, I more than welcome them. Next video will be on addition and subtraction of decimals, and then we will have multiplication and division of decimals, followed by one more on expressions that involve decimals. And for now I will be gone in 3, 2, and 1.